All right, class. So in today's lesson, what we're going to try to focus on is finding the x-intercepts of parabolas slash quadratic equations. Now, just to give you a couple things about that is that the points where the parabola intersects the x-axis, that is called your x-intercept. They also have other names like solution, zeros, and roots. Okay. Now, for us, we can find the x-intercepts by solving for x. Now, for us to solve for x, we need to fully factor the quadratic. We're going to take both of those binomials, we're going to set them both equal to 0, and then we're going to solve for x. And then once we solve for that x, we're going to make two order pairs, and those order pairs will be our x-intercepts, there will be our solutions, there will be our zeros, and there will be our roots. Okay, so now let's look at our first example, and from there we'll get a better understanding what I mean by fully factored, what I mean by setting them equal to 0, and then solving for x. Okay? So now let's look at our first example. All right, so let's look at example 1. In example 1, we have y is equal to, in our first group, which is 2x minus 2. In the second group of parentheses, we have 5x minus 15. Now, because this is not set up like a regular polynomial where we have ax squared plus bx plus c, and we have to factor it down, this one's kind of already factored for us into two separate binomials. And because of that, we can go ahead and jump to step 2, where it says that we can take the two binomials and set them equal to 0. So if I do that with this problem, set them equal to 0, my first one will be 2x minus 2 is equal to 0. And the other one will be 5x minus 15 is equal to 0. And with that being equal to 0, now we can solve for x. Solving for x means I'm getting everything away from the x, okay? So I'm going to take the negative 2 and I'm going to add 2 on both sides. When I add 2 on both sides, that cancels that out, and this brings my 2x down, okay? 0 plus 2 is going to give me a positive 2, and I can divide everything by the number that's beside my x, and the 2's that's with my x's will cancel out. 2 divided by 2 will give me 1, so for this one we'll get x is equal to 1. On the other side, if we take care of that, that means we got to add 15 to the other side or move 15 to the other side of the equal sign, because we want to make sure we do everything we can to get x by itself. Okay, so my 15s have been moved. That's going to give me on that one side a positive 15 because it's 0 plus 15. And then I can bring down my 5x. Now, because there's the only thing left on that side is with my x is the 5 and it's attached, that's division. So that means I can divide everything by 5. The double 5's cancel each other out because I moved it or made it 1. So that means the x is by itself. Now we got positive 15 divided by 5, which will give us 3. Now that we have solved for the x's, we can set up or write our two order pairs for our x-intercepts. So the first order pair that we will have will be 1, 0, and the other order pair will be 3, 0. So because they're x-intercepts, they go in the x spot of an order pair, which is the first number. Second number will always be 0 when you're looking at just your x-intercepts, okay? So now that's example 1. Let's move to example 2. All right, so now looking at example 2, if you look at this one in comparison to example 1 was broken already into two binomials, but in example 2, we have a full quadratic where it's the ax squared plus bx plus c. Okay, so that means we have to fully factor this before we can do step 2, which is setting the two binomials equal to 0. Okay, so let's go ahead and do our factors for this problem. Now, the first thing we check when we go to factor is that if we have a GCF. So for me, I'm going to use Desmos to help me with my GCF, and that means in Desmos, I'm going to type GCD, okay, parentheses, and then I'm going to type all three of my numbers, which is 2, 9, and 10. Please notice that I separated all three of the numbers with commas, okay? And it told me that my greatest common factor between all three of these numbers is 1. And because all of them only share 1, there's nothing that I can take away from them, okay? So that means I can list my A, B, and C. So my A is going to be 2, my B is a positive 9, and my C is a positive 10. Now from that point, I need to get my A times C, which is the top of my X. So I'm really trying to just fill in my X so I can factor it. So A times C, which will be 2 times 10, which is 20. Okay, so that positive 20 will go to the top. At the bottom of my X will be my positive 9. And now I need to go get all my factors of 20. So all my factors of 20 will be 1 and 20, 2 and 10, 4 and 5. Okay, now out of my factors, I need to find the one that will give me 9. And just looking at my list, 4 and 5 will be the one I used. Okay, now at the bottom of that, I got to make sure I write my A value. So there's going to be a 2 here and a 2 under that 5. Now the signs are important. I have a positive at the top and a positive at the bottom. So that means my signs for both my 4 and 5 will be positive as well. All right, then I look to see if anything can be simplified. 5 over 2 cannot be made smaller. 4 over 2 can be made smaller by simplifying both of them by 2. So that's going to give me 2 over 1. And the 2 still stays positive. Okay? Now if we do our bottoms up, the bottoms up says that I will do 1x plus 2. And for my other side of my x, it'll be 2x plus 5. All right, so now we fully factored that. Now once we fully factor, what we're going to do is we're going to set it equal to y. Okay, now that I have my 2 fully factored or my 2 binomials, I can set them equal to 0. So my first one, I'm going to do x plus 2 is equal to 0. And the other one, I'm going to do 2x plus 5 is equal to 0. Now with that, we'll go ahead and solve for x for both. So we're going to subtract 2 on both sides for the first one. 2's cancel out. What we're going to be left with is x is equal to negative 2. And for the other one, we're going to subtract 5 on both sides first. Goes away, bring down my 2x. And then that's going to bring down to negative 5. I can divide by 2 on both sides. So x for this one will be negative 5 over 2. All right, so now that I have it solved for x, the last thing I'm going to do is write my 2 ordered pairs. And my 2 ordered pairs for this one will be negative 2 and 0. That's one of my intercepts. And my other intercept will be negative 5 over 2, comma 0. All right, so that is the full process of what we're going to be doing when we go through to find intercepts using just the equation. Okay, now let's move to example 3. All right, so now let's look at example 3. Example 3 gives us y equals 5x squared minus 20x plus 15. Now with that, that means we have a regular quadratic or polynomial that follows the standard form, which is ax squared plus bx plus c. What that means, we have to fully factor it before we can find our x-intercepts. So let's start the factoring process by checking to see if we have a GCF. If we have a GCF, we'll go to Desmos to test it. If we do have one greater than 1, that means we'll have to divide it out. So let's test. So in Desmos, I'm going to type GCD, and I'm going to type in my 3 numbers. And I do have one greater than 1, which is 5. Please notice that in Desmos, I made sure that I separated my 3 numbers with a comma, and it gave me 5, okay? Now, that means because my GCF is greater than 1, I have to divide everything by that GCF. And when I do that, I get a simplified version of my original problem, which will be 1x squared minus 4x plus 3. That tells me that my A is now going to be 1 my b is now going to be -4, and my c is now +3. So I can go ahead and set up my x, which is starting with a times c, which is 1 times 3, which is 3. So at the top, we're going to put a +3. At the bottom, we're going to put our b value, which is -4. And off to the sides, our a, we're going to put 1 underneath that until we get our factors to go at the top. Okay, so our factors of 3 is only going to be 1 and 3. So we can go ahead and put those there. The most important part is making sure that our signs are correct. We have a positive at the top and a negative at the bottom. So, and with that being what I need, both of my signs are going to be negative, because a negative times a negative make a positive. And if I add two negatives, it makes the -4 at the bottom. So that is that. Using my bottoms up method, that's going to give me 1x minus 1. And we're going to have 1x minus 3. And we're going to make sure that, because we had to take out a GCF, we're going to make sure we put our 5 out front. Okay? Now that we have it fully factored, we're going to go get our x-intercepts. And to do that, we're going to take and set each one of our binomials equal to 0. Okay? So if we do that, that's going to give me 1x minus 1 is equal to 0. And the other one is 1x minus 3 is equal to 0. So let's solve them. We add 1 on both sides. 1's go away. That leaves me with 1x is equal to 1. Divide by 1. So the first one is x is just 1. The other one, I'm going to add 3 on both sides. That's going to give me 1x is equal to +3. Divide by 1. X is just 3. Now I know what my x's are. Let's write our order pair, and then we'll be done. So our order pairs will be 1 and 0. And the other one will be 3 and 0. So those will be my two x-intercepts for example 3. All right, we have completed our examples. Now that we have an understanding of how to get our x-intercepts. Now remember, x-intercepts can be called solutions. They can be called zeros. So there's multiple names, but the way that we solve is by factoring first, making sure we have a fully factored quadratic polynomial. Once we do that, we'll take the two binomials, set them equal to 0, and we'll solve for x. And then we'll write our two order pairs, and that's how we actually find our x-intercepts. All right. Now, if you have any questions, don't hesitate to ask.